Welcome to this new series of video concerning geographic information system. The last time we were talking about the basic information, basic knowledge on geographic information system. But today we will try to go a little bit further, discover some new thing about geographic information system. So here we will study the environmental geographic information system. I am Dr. Nduse Marcelos. I will lead you through this series of teaching. Thank you to watching and listening to me. First of all, let's talk about data type. Data type in geographic information system. There are three main types of data when concerning geographic information system, and those three main types will be listed as spatial data, attribute data, and metadata. As you are seeing in this presentation, we have spatial data, metadata, and attribute data will stand also as non-spatial data. And all this is component of data that we will find in geographic information system. Okay, let's talk about data source. The type of data is primarily the measurement collected through the first-hand observation, and the secondary type will be measurement collected through a secondary source, for example, neighborhood survey. And let's talk about metadata. What we need to know is that metadata are data documentation, data about data. Explain the form, the content, the accuracy, the precision, the usability, the creator purpose, and many other things. And we have metadata standard that exist. And we also have metadata that is a part of geospatial data. Metadata is a part of geospatial data. All this involved is metadata. Metadata information include identification, the title, the area, the date, the owner, the organization, etc. And what we want to talk about data quality. Data quality will also include, when we talk about the metadata information that is included inside metadata, we talk about data quality, attribute accuracy, and spatial precision. And consistency, source of information, and method of data production. All these include in metadata information. We have also spatial data organization. And as a metadata information component, we have raster and vector format and organization of feature in data set or in data model. We have also what we call spatial reference, map projection, datum, and coordinate system. If you remember well, during our past lecture, we presented it already. All right. Metadata also, as we are saying, metadata also is created to do what? We need to understand what is the purpose of metadata. The purpose here is to protect investment in data, through which we can see the staff turnover, memory loss, make it easy to reuse and update data, make it easier to reuse and update data. It provides documentation of sources, quality, and it helps also the easy to share data. Another part of objective of metadata is it helps the user to understand the data. It provides consistent terminology, focus on key elements, and it helps user determine fitness for use, facilitate data transfer, interpretation, by new user. That is all the objective of the metadata. That is very good to understand. All right, let's try to see now catalog to create and edit metadata. We have the software that we call Art Catalog. This is how it will represent. It will help us to create and edit metadata. And as you see here, there is the onglet, that is a window that will help us to know how to edit, upgrade, validate, import, or even print some element that we are studying. Database model. Now, let us see what it is. First of all, new in our former knowledge concerning database, we know that the database is a collection and non-redundant data which can be shared by different applications in the system. And the geography database is nothing but the data linked to geographic data for a particular area and subject. For example, we have here the map representing the world, many continents, the world, America, Africa, Asia, Europa. And here we have a table, or let's say an information about those different countries that we can find in this map, and we classify them by their code, the country, the population, the area, the size of the area. This is an example of those representations. And now, as we talk about the attribute data, it's very important. So, the way of geographic information system is determined by the spatial data. Here is linked to a location, a specific location. The what, because here we talk about the where and the what. The what is determined by the attribute data. The attribute data. So, the where is determined by the spatial data, and the what is determined by the attribute data. The attribute data is just as important as the spatial data. You cannot just study the what, you need to study also the where. Okay. And let's see this example of attribute of migration pattern inside the database. We have here the shape, the area, the perimeter, the state, the immigrant, the out immigrant, and the net. For example, with the shape of polygon, we represent those areas. The perimeter, we can present it in size, the area also in size, the state where they belong. We have Alabama, Arizona, Kansas, California, Colorado, Connecticut, Delaware, District of Columbia, Florida, Georgia, Idaho, Illinois, and many other places that we can study. So in this window, we will present attribute data stored in a database table, help you to understand how linked, how closer the geographic information system is close to database management system. So there are two fields that really work together. Now let's talk about database. The link, as we are saying. Advantage of database management system include reduce redundancy of data duplication. Various data access methods are possible, what we call queries, that is stored independently of the application for which there will be use, because we can make up a database and have many other different applications across the connectivity inside the world, in the way that everybody can retrieve the information into a database without being obliged to have a particular application that is imposed. that when we implement something like that, it proves that the database is well done. And data is stored independently of the application for which they will be used, as I always say, and access to data is controlled, and data is centralized and easy of updating and maintaining data. When the database is well implemented, it's easy to be updated. It's also very easy to be maintained. In the case where we face a crash in the system, we are not just build a system that when there will be a crash, everything will be over. You must make a system such a way that it can be self-improve against crash. All right. So, in this part, we will study the geographic information system. And right now, let us see how we can create those databases. In this part, that concerning creating a database. Consider the following: storage media. How will database change over time? What security is needed? Should the database be distributed or centralized? How should database creation be scheduled? We need to know it, all those elements, before creating a database using whatever system management for database. We first of all need to ask ourselves this question about the storage media. Ask ourselves about how will the database change over the time, the question of the future of data that we want to implement, and what security is needed, because the security factor is very important while concerning database. Security factor is very important because if you implement a database and you don't take charge of those security aspects, you may put the entire community, entire enterprise in problem, because security aspect will involve the fiability, the independency, the disponibility of the data and the server, and also the authenticity, so that we must be able to even what we call access control. And the authentication will help us to really know that the person that will have access to the data must be that person really that is supposed to have access. And we need to think all those things to implement the project. And we need to know now the architecture. Should database be distributed or centralized? Should database creation be scheduled? We need to ask ourselves all those questions. Now, what we call cold principle for database. Only one value per cell. All value in the column are about the same subject. Each row is unique. No significance to the sequence of column. No significance to the sequence of row. And keep your table very simple. That is some advice to and some principle to build your database. And the attribute type for database, we have the qualitative domain of attribute type. You must know measurement or magnitude, no numeric description, no numeric meaning, even if shown as code number. For example, what1 that's equal to category 1. And the quantitative aspects of attribute type. In that quantitative aspect, you must know the numeric and have mathematical meaning, serve as measurement or magnitude of the feature they refer. Example, we have the city population. Now, the type of database. Database is relational. Present data organized in a series of two-dimensional tables, each containing record for one entity. And now we have the relational database that must be flexible approach to linkage between record, come closer to modeling the complexity of spatial relation between objects, link attribute contained in the separate file with a key attribute. Very important. The key attribute is usually a non-redundant and unique identification number for each record. The most popular database management system model for geographic information system. Now, let's talk about the data. Most data is input into a database by key coding. Other data may be obtained through government source, for example, US Census, NOAA, state agency. Data may also be obtained from other projects. Yes, can be also obtained by other projects. Method of spatial data entry. We can have manual methods, head-up digitizing. For example, we can also have scanner, appropriate for encoding raster, since this is the output format for most scanner. Problem may include scanning unwanted information, optical distortion. The higher the resolution, the more volume of data is produced. And let's see now the method of spatial data entry. We can have method like electronic data transfer, downloading data from the internet, downloading data from a GPS unit. Consider when obtaining electronic data, what data is available, the cost, the media, the format. That's some method of spatial data entry. Okay, source of electronic data. Those different sources can be United States Geological Survey, as we already said. That may include digital line graph, digital elevation model, digital orthophoto quad, and we have also United States Census Bureau. That may include topologically integrated geography encoding reference system that we call TIGA. And we have also first comprehensive geography information system database at street level for entire US. And we have United States. We have National Oceanographic and Atmospheric Agency, NOAA, satellite and radar image, bathymetry map. This is very important at time even to prevent some crash, some natural disaster. It's very important to study all those domains. It helps us to really prevent and know how to take decisions. In computer science, the main objective of computer science is to facilitate people to take decisions concerning the information around us. That is the main objective of computer science. And even if today we are studying artificial intelligence in the world of object connected world, we need computer science to be improved so that it can help us to facilitate the decision taking around us. All right, in this series we see all those elements concerning geography information system, and I hope that you succeeded to gain more knowledge through this tutorial, and we will end up in this area, and I will see you the next time for another video. Thank you for watching, and let's see the next time.